All right, in this series of lectures, I'm going to introduce dynamic programming. We're going to start off fairly simple, and then it'll get more complex as we go along. It's an incredibly useful technique. You're going to see it pop up in a lot of places. So it's something that if you've done LeetCode, code, you'll see a lot of LeetCode code that's dynamic programming, and it shows up in Java interviews too. What you're going to be looking for is optimal substructure and overlapping subproblems. These are two sort of things that will clue you in that dynamic programming might be the right way to go. And if you can see how the solution works, the code is usually very, very simple. I'm going to start off with Fibonacci. This is about as simple as I can think of to show you how dynamic programming works. Classic definition, Fibonacci of 1 or 0 is 1. Otherwise, you make a recursive call, calculate Fibonacci of n minus 1, add it to Fibonacci of n minus 2, and that's your Fibonacci. The downside here is the call tree sort of blows up. If I come in here with Fibonacci of 5, I make a recursive call to Fibonacci of 4, and also a recursive call to Fibonacci of 3. This Fibonacci of 4 calls to 3 and 2, and it keeps on going. It's going to blow up, get larger and larger and larger. And here's Fibonacci of 7. It's going to get bushy, and if you throw a large number at this recursive Fibonacci, your code is going to run pretty close to forever. There's a better way to do this, and it's dynamic programming. The idea is you're going to store a partially computed sum. You're going to store things that are useful, and rather than recomputing, you're going to use the old value. So we've got here Fibonacci of 4, Fibonacci of 3. If I store Fibonacci of 3, I don't have to recalculate this one. And so there's simple C code. I've got a table where I'm storing the numbers, fill in Fibonacci of 0 and 1 into the table, and then I've just got a simple for loop going 2 all the way up to my value of n. When I need Fibonacci of 3, I pull the number out of the table for 2 and 1. When I need Fibonacci of 4, I pull the number out of the table for 3 and 2. So I'm just filling this in as I go, and I don't have to make any recursive calls, and the tree is not going to push out. It's linear time rather than something that's exponential. This is the easiest one I can think of, but there's a ton of variations, and they're all using the same trick. It's a really good trick. So subsequent lectures, we're going to go through rod cutting, matrix chain multiplication, longest common subsequence, all sorts of things. Same trick, same idea. If you can get comfortable with Fibonacci, you'll be able to get comfortable with everything else.